Solving linear equations. The solution of an equation is the value of the variable that makes the equation true. To find the solution, you need to get the variable alone on one side of the equal sign. To do this, you're going to use the inverse operations, an operation that undoes another operation. So the inverse is the opposite of the operation going on. So inverse operations. The inverse, or what undoes addition, would be subtraction. So in an equation, if you have addition and you need to isolate the variable, you would do the inverse operation of subtraction. And the inverse of subtraction is addition. Now when we do the inverse operation for multiplication, we'll have to divide. So the inverse or opposite of multiplication would be division. In algebra, the way we see multiplication would be a number attached to the variable. When we have a number attached to the variable, the operation that's going on is multiplication. So the inverse or the opposite, you would have to do division. And then the inverse of division would be multiplication. And the way that we'll see division in an equation would be a variable over top of a number. Remember that line means division. So when you see an equation that has a variable over top of a number, what that means is that variable is being divided by that number. So in order to isolate the variable, you're going to have to do the inverse operation of division, which would be multiplication. So we're going to start with one-step equations. And in this equation, I have a negative 10 plus x equals a negative 4. Now I need to isolate that variable. I have to get the variable on one side of the equal sign by itself, which means whatever is with that variable, I need to do the inverse operation to get it to the other side. So in this case, that negative 10, I need to do the inverse, which would be plus 10. And whatever you do to one side, you have to make sure that you do it to the other side of the equal sign. So always make sure that you're crossing to the other side of the equal sign when you're solving equations. Now from left to right, notice that negative 10 plus 10 will be 0. It gets eliminated. And you're left with x, and then you have to do the arithmetic. So x will equal, and then I do the negative 4 plus 10. Different signs mean you're going to subtract and keep the sign of the higher number. So you'll end up with a positive 6 as your answer. This next example, you have x plus 8 equals a negative 2. I want to isolate the variable on one side of the equal sign, so I'm looking to see what is with the variable. And in this case, I have addition. So the inverse to addition would be subtraction. And whatever you do to one side of the equal sign, you have to do to the other. So I'm subtracting 8 from both sides so that I can isolate the variable. So I'm left with x, and that plus 8 minus 8 will cancel, bring down that equal sign, and then do the arithmetic. Negative 2 minus 8, same side, add and keep the sign. So you end up with a negative 10. So this next one, I want you to notice here that I have x over a number, and that number is a negative 4. Well, this means that x is being divided by a negative 4. And when you have division, you have to do the inverse operation of division, which is multiplication. So I'm going to multiply both sides by a negative 4 so that I can eliminate that negative 4 and isolate the variable. And whatever you do to one side of the equal sign, make sure you do to the other. So that negative 11 is going to be multiplied by that negative 4, and you'll end up with x equaling a positive 44. because negative times a negative is a positive. Now this next one has a number attached to the variable, and whenever a number is attached to a variable, the operation is multiplication. So I need to do the inverse operation, and I like to show the inverse operation or division the same way I would see it in an equation. So I'm drawing the line and putting the 5 for division, and whatever you do to one side, you have to do to the other. Now notice 5 over 5 will cancel to 1. So we end up having the variable by itself, and it's going to equal 35 divided by 5, which gives us 7. So notice this. You might get to the point where you think you're done solving the equation, but you end up having a negative left with the x. Well, if there's a negative sign left with the x, that means that you haven't completed the solution, because really what you have is a -1. And when you have a -1 attached to x, you need to do the inverse operation, and when it's attached, it's multiplication, so the inverse would be division, and whatever you do to one side, you have to do to the other. So you divide through by -1, that's going to cancel out that negative sign, and you're going to end up with x equaling a -19. So be really careful that you don't leave a negative with the variable that you're solving for, because you haven't completed the solution. Pause and try. So in this case, you had to subtract 16 from both sides. You had different signs, so you're going to have to subtract and keep the sign of the higher number. So you should have gotten that x equals a -12. Pause and try. So now this case, you had to add 3 to both sides. So you should get that x equals 0, because -3 plus 3 equals 0, and our variable can equal 0. So we end up getting x equal to 0 with this solution. Pause and try. So this is multiplication. The inverse would be division. We have a negative divided by a positive, so we're going to end up with a -6 as your solution. Pause and try. So this is division. The inverse operation of division is going to be multiplication. So that 5 times x over 5 will cancel, and you're left with a -2 times 5 gives you a -10. Pause and try. So you have to add 0.16 to both sides. Now keep in mind, you have to remember how to add decimals. When you add decimals, you have to line up the decimal spot. If there's a missing decimal piece, you're going to put a 0 in that spot, and then you're going to add down. So we end up with 3.36. Pause and try. So now this is fractions. So you're going to have to subtract that 3/7 from both sides. But in order to subtract fractions, you must have a common denominator. So in this case, the common denominator is simply going to be 35, because the denominator of 5 and 7 are prime numbers, and the only way to get the common denominator is to multiply the two denominators together. So I'm going to convert the fractions, the first fraction by multiplying the top and the bottom by 7 over 7. The second fraction I'm going to multiply by 5 over 5. So my converted fractions will be 14 over 35 minus 15 over 35. So you have different signs, so you're going to have to subtract and keep the sign of the higher number. So we end up having a -1 over 35. So this next example, we have a fraction attached to the variable. So now this is where you need to think in terms of, how do I get rid of a fraction that's attached to the variable? Well, remember that reciprocals, when multiplied together, they give you a product of 1. And that's what I need to have for the variable, a coefficient of 1. So to get the product of 1, I'm going to take the fraction that's attached to the variable and multiply by its reciprocal. but I'm also going to need to get rid of that negative sign. So I'm going to multiply by a negative reciprocal. So I'm going to end up having a negative 4 over 5, and I need to do to both sides of the equal sign, because what you do to one side of the equal sign, you have to do to the other. And it's multiplication here. So keep in mind, reciprocals are going to cancel out, and that's what's going to get me the variable by itself. Now, when I'm doing the multiplication of that fractions, I'm going to have to simplify first and then multiply across. Don't forget the signs. I have a positive times a negative, so I'm going to end up with a negative, and I end up with a negative 3 over 10. Pause and try. So you're going to multiply both sides by that reciprocal and also the negative sign so that I can get rid of the negative that's attached to the variable. It's going to simplify, and I'm going to end up doing the multiplication of that fraction to fraction, and I'm going to end up with my variable equaling a negative 4 over 5. So now we want to work with two-step equations. Two-step equations, you always want to follow these steps. Get rid of any plus or minus first. So with a two-step equation, if you see a plus sign or you see a minus sign, the first movement you're going to make is to do the opposite or undo the addition or subtraction. Then you'll do the multiplication or division. Now remember, multiplication or division will be attached to the variable. So you don't want to work with what's attached to the variable until you deal with what's around it, which would be that addition or subtraction. So here's an example. I have 8x plus 5 equals 61. Well, I don't want to deal with that 8's that attach to the variable first. I want to get rid of the plus or minus first. So in this case, I have a plus 5, so I have to do the inverse of plus, which would be subtraction. And whatever you do to one side of the equal sign, make sure you do it to the other side of the equal sign. So what's going to be left here after I subtract the 5 is that 8x will come down. The plus 5 minus 5 cancels off. My equals comes down, and then I do the arithmetic. 61 minus 5 will equal 56. Now I will deal with what's attached. So now I have 8 being multiplied to x, and the inverse of multiplication is division. So I'm going to divide both sides by 8 to isolate that variable. So I end up getting x equaling 7. Now notice this next example, my variable is on the other side of the equal sign. It doesn't matter which side of the equal sign the variable is on. What matters is to get it on that side by itself. So notice here that I have a 4a plus 10 on the side that the variable is on. Well, I don't want to deal with the 4 that's attached to the variable first. I want to remove that plus 10. And to remove it, you have to do the inverse of plus, which is minus. Whatever you do to one side, you have to make sure you do to the other. Now you're working from left to right. You have 18 minus 10 is going to give you 8 equals, and then that 4a will come down. And that plus 10 minus 10 cancels off. Now you're dealing with where the variable is. And notice here, the variable has attached to it 4. And to remove it, because it's multiplication, the inverse would be division. So you're going to divide both sides by that 4 to get the variable on one side by itself. So you're going to divide both sides, and you're going to see here that a will equal 2. This next example, you see here, I have a negative 4 plus 7x equals 3. I want to isolate the variable, which means I need to deal with that negative 4. And to remove that negative 4, you have to do the inverse, which would be add negative 4 to both sides. So you add 4 to both sides, that's going to get rid of that negative 4, and you're left with 7x equals 3 plus 4, which is 7. Now you'll deal with what's attached to the variable. And remember, when something's attached, it's multiplication. The inverse would be division. You're going to divide both sides by 7, and you'll get your solution. Your variable, or x, equals 1. So this next one, you have to be careful. I need to solve for the variable. I have to isolate the variable to one side, which means I want to first deal with the 15. I'm not going to deal with what's attached to the variable. I'm always going to get rid of what's around it first. And what's attached to the variable, you'll see, is really going to be a -2. So I'm going to remove the 15, and to remove it, because it's positive, I have to subtract it from both sides. You're subtracting it, so you're going to be left with, and that minus now becomes a negative. So that minus comes down with that 2, and you have a -2x equals, and then you have 11 minus 15. Different signs mean you're subtracting, and you're keeping the sign of the higher number. So you end up with a -4. Now you're going to deal with what's attached to the variable. You have a -2, it's being multiplied to x. The inverse will be division. You're going to divide both sides by that -2, and you're going to end up with your x equaling a +2, because a negative divided by a negative will be a positive. Pause and try. So you're going to first subtract 5 from both sides. Then you're going to deal with the number that's attached to the variable. You have to divide both sides by 7. You should have gotten that k equals 5. Pause and try. Be careful here. The first move you have to make is to subtract that 8. You subtract that 8 from both sides. You have same signs. So you're going to add and keep the sign. You end up with a -99 equals 9x. Now you'll deal with the division. You're dividing by what's attached to x. 9 is attached to x. You're going to divide both sides by that 9, and you end up with a -99 divided by 9 will give you a -11. So your variable here, or x, equals a -11. Pause and try. So the first thing I'm going to do is add the 6 to both sides. You're left with 12t equals 36. And then you're going to divide through by that 12, and you should have gotten that t equals 3. Pause and try. So be careful here. You have to subtract that 11 first. What's going to come down is that -3 with that x, -3x. And now you're going to divide through by that -3, and you're going to get x equals 2. Pause and try. So now this one, x is on the right-hand side, and that minus is with the 3. That's attached to the x. Your first move is to get rid of that 4. To get rid of the 4, because it's positive, you have to subtract it from both sides. Now you're going to be left with 21 equals, and that minus now comes down attached to the variable as a negative, so it's a -3x. You're going to divide through by that -3, and you're going to get your solution for x is going to equal a -7.